So, a new paper on the topic of inclusion and outreach in phylogenetics. I conceived of this work listening to a podcast on NASA representing data as audio, and I went and represented phylogenies as audio. So, but there's been some earlier work on this. So earlier work on representation of phylogenies as audio and video. Mainly this article in a obscure journal. Obscure, it's difficult, doesn't really have a DOI, I believe, but it is easy to find and read nonetheless. But you can see here they have suggested how to represent a simple small phylogeny as a set of notes. I think this would only really be appropriate for very, very small trees. Anyway, it's just an outline. They don't present any tools to do this, and they haven't actually made any files available. Otherwise, I would point out there have been some like documentaries and other promotional videos where they've represented phylogenies in some kind of video form. Here's one mentioned in Saltis and Saltis, and I remember this documentary also, which I couldn't find a still from this, but I seem to remember they also showed phylogenies in kind of video form. What this attempts to do, which is different, is to have more of a framework for conversion of published results on the topic of the tree of life in audio and video form, not just like some one-off file. Oh, I should say one other piece of work dated from 2019 by Wayne Madison, who studies the evolution of spiders, and something similar. Wayne in his presentation shows a phylogeny and represented, I'm not sure the audio will come through here, but it represents as a set of tones. I'm not sure this is directly the branching, it might be some evolutionary events overlapped on the phylogeny. In any case, I'm not sure Wayne has done any further work. I've not come across any other work on this, but here's another example. And you can see, as part of the paper itself, 56 published phylogenies converted to audio and video form, and I've done a bunch more also. So why would this be done? One obvious reason is to widen the participation for sight impaired learners, for instance, is otherwise quite limited options for experiencing results of research into the tree of life. But it can be done through, say, tactile examination of specimens, but you can see the range is very limited. More generally, there's evidence that phylogenies or data presented in multimedia forms will have some benefit to learners. So the first time I had this actually working, it was the first upload August 2021. So it's been developed over several years. And here's one of the latest. So this is the representation video form I'm tending to use at the moment. Simple black background and white branching with some node characters, and you can see that these are scaled at the start of the video. The items are somewhat larger when there's less things on the screen. So for example, you can read more easily as we get to the terminus. There's a lot more items on there, and these are represented somewhat smaller. And I'll try now to have the taxonomic information on there. This makes the pipeline a bit more complicated, but the principle is pretty simple. As long as you can read the terminal IDs, and for any node you need to read the set of terminal IDs and what is the shared taxon, and then that becomes the name, and the name is then printed at the appropriate point along the axis. But the essence of the pipeline, we need analyzable data, and so I've only used machine analyzable data phylogeny files which have been provided with a Creative Commons license. So this permits any kind of subsequent uses. So these tend to be found at data repositories like Dryad. There's some basic standardization, particularly these needs to be oriented correctly, regardless of what is printed in a phylogeny study, in the paper, in the figures. What's provided as data tends to be a lot more messy, even they can be unrooted, so actually even have to check the routing. I prefer to remove outgroups if possible, and order the clades by increasing size top to bottom. Then we interpret the branches as a set of tones. So we have the typical orientation of a tree from root to tip. Then we can say, okay, so root is time 0, the terminus is time, say, 30 seconds, and then we need to have the branch length information. It tells us at what time the branch event starts and stops, and we represent this, put a silence segment and then some kind of noise and then a silence after it. And the amplitude or the volume needs to be reduced in kind of this. So you hear clearly where the branch starts, but you need to create sort of auditory space, or is limited number of tones you can represent. So you create this waveform, and I suggest the frequency range is this is typical audible frequency range, about 200 to 900. We can use this then to set the frequency according to the position on the y-axis where the branch starts and ends, corresponding to a typical visualization. So, for example, this would have a higher frequency, and it would not drop like this. You wouldn't really, because there's no time here, so you wouldn't actually hear this. You get this decreasing frequency in addition to the reducing amplitude. Then you convert a whole bunch of branches accordingly, and make a corresponding video if you wish. And a bunch of commands, you can do this, and the code is all available. And this figure shows, as I say, I want to represent potentially any published phylogeny, as long as the data is available. So you don't want any conditions, you don't want to say, okay, this is the type of phylogeny can be represented. You don't want any limitations. So it means very large phylogenies would be nice to have these also. And this figure just shows the kind of things you have to do if you're trying to represent a very large phylogeny. You can't have 100 tones occur in a given second, or it becomes inaudible. So you need to have ways to represent where you have dense branching, and one way is just to have this sharp tonal decay in volume or amplitude. And a bit of depiction of taxonomic names. I try now to do this for the video. I have implemented doing this for the audio. It's not really a satisfactory solution at the moment. So it's called text to speech, where you have a word and you have a computer tool to speak that word. So it's fine for commonly used words, but specifically for taxonomic names, this doesn't really work particularly well. Nonetheless, have implemented it, and hopefully that can be improved over time. And because this is also about outreach, so I opted to upload these to popular media sharing platforms. So each of these audio files or video files has been available at 3 popular locations. And that's about it. So an example of how we might better respond to obligations in widening participation and also promoting phylogenetics. And I've gone through the code itself elsewhere, so I won't cover that here.